Hi there. This is a video that will act as a tutorial for using data collected in the lab, which involved water displacement and measuring mass values of a metal, and using a spreadsheet to create a scatter plot of that data, insert the best fit line, and calculate the slope of that line. And I am going to walk you through the assignment, and you should pause as needed to enter data or complete actions as I do them. And then when you're finished, you can continue on. So the assignment is called the Water Displacement Graphing Assignment. And when you click on it, you're going to get a screen that looks kind of like this, and there'll be a My document. And what you'll want to do is you'll want to open that document up in another tab so that it's as big as it can be. And that tab, that document is going to look like this. It's called NWTC Water Displacement Data Analysis. It will have your name in front of it. So this is going to be a copy that's made for you. So in class, in each of the hours, there was data collected using water displacement for an unknown metal. It was a bright, shiny metal. I was actually going to bring it here for this video, but I forgot to bring it over here. And there are two sets of data that I want you to use, both hour 1 data and hour 2 data. It appears that you will have to download the attachments to view them. And I want to emphasize again, you will need both hours data for this activity. So hour 1, it looks like this. It has the starting volume, the ending volume, and mass information. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 measurements in the year that this video was made. If I continue to use this video in future years, your attachment for this activity may look a little bit different than this one does at this time. So this data will need to be entered. And the hour 2 data looks like this. Again, we have an initial volume, a final volume, and mass. So in the spreadsheet, shoot, I accidentally tried opening up Excel. In the spreadsheet, of which yours looks like this, what I would like you to do is I would like you to put the mass measurements or the initial volume measurements in, the final volume measurements in. I didn't count how many there were in the second batch, but you need to make sure you include them all, and then the mass in this column. So when you are finished with that, you will end up with a data set that looks similar to this. Again, I don't know how many total measurements there'll be because I started counting one and I didn't count the other. But you have your initial volume, your final volume, and your mass information. So at this point, I would like you to pause this and take the data from hour 1 and hour 2 and enter it into your copy of the spreadsheet. Okay, if you're watching, it means that you have gotten your data up to this point, and you have a column of initial volume, you have a column of final volume, and you have a column of mass. The spreadsheet is set up this way for a reason. And I'm going to teach you a little bit about graphing within spreadsheets if you don't have a lot of experience with that. And if you do, just some reinforcement. So I will also be teaching you how to do calculations in a spreadsheet, which is a very easy thing to do. So when we used water displacement, I'll just refresh your mind here. I had a graduated cylinder, and it had a certain amount of water in, which was the initial water. And then I put the objects in, and the water level went up. The objects were there. So the volume of the water is going to be equivalent to that difference. So what we want to do here is we want to write down what the volume of the metal is. And it's very easy to calculate a difference. And you could do it by inspection, but we're going to use it a different way using equations in a spreadsheet. So whenever you type in an equal sign, it means that you're going to tell the spreadsheet to perform a specific operation. Now, what I want to do is I want to take the contents of the final volume and subtract it from the initial volume. And when I hit enter, you'll see that the number shows up there. So again, I type in an equals to let it know that we are going to use this to perform a mathematical operation. Equals, I could also type it in B2 minus A2, enter, and we get 9. Now, the really handy thing about this is you don't need to do that each time. So what you can do is you can click on the box that you just made the calculation in and hover over the little blue square until you see a plus sign. When you see a plus sign, click and grab and then drag it all the way down. And the spreadsheet does all of those mathematical operations for you. So very quickly, we just did a lot of mathematical operations. Spreadsheets are powerful. All right, the next thing that we want to do, and this has something to do with graphs in spreadsheets in general, is for this activity, we want to make a graph of mass versus volume for a set of data that was collected just like this. So mass versus volume, when you have something versus something, it's always the y-axis versus the x-axis. So we're going to create a graph in which mass is on the y-axis and volume is on the x-axis. Y versus x, mass versus volume. When we want to make a graph or a chart, and there are two columns of data like this, the first column is always going to represent the x-axis, and the second column, the one to the right of that, is always going to represent the y-axis. So this metal volume, we want that on the x-axis, which is why in the template that I provided for this assignment, I have this column right here to set you up for making this graph. Now, if we have a series of data like this, and we produce a scatter plot, and then put the best fit line in. I'm trying to give you a vision of where we're going with this. The slope of this line is equivalent to an experimental density. So the slope of a line on a graph of mass versus volume is going to be equivalent to the experimental density. So that is the direction that we're taking with this activity. I'm going to clear the annotations at this point so I can show you the next step. So we want to make our scatter plot. And what we want to do is we want to highlight both columns. Remember this, the metal volume column is going to be on my x-axis. The mass is going to be on my y-axis. So I highlight both columns like that. And if you want to pause it and do this with yours, I would encourage you to do that. And we go to Insert, Chart. Now it may show up as a scatter plot and it may not show up as a scatter plot. If it doesn't, then we want to choose the chart type to be scatter chart. All right, but it did. And this is the graph that it has produced. And you'll notice that it says mass in grams versus metal volume in milliliters. What it took for the title was the headings that we had here. So you can see that this is a pretty straight line. The next step, I'm just going to move this over a little bit because I don't need the data anymore, is to customize this graph. We want to put in the best fit line. So we click Edit Chart, Customize. I think we click on Series, and we choose Trend Line. And we want it to be linear, not exponential or polynomial. Doesn't look that much different, or logarithmic. So we want it to be a linear graph or a linear trend line. Now, when we scroll down a little bit, there's this little box here that says Show R squared. And that used to be something else. I have to pause this recording right now temporarily because it is not the normal thing that it used to be. So I'll be right back in a moment. Okie dokie, I figured it out. I just clicked the wrong thing. So once we have our trend line, we want to, I seem to have lost it already. Click Label and choose Use Equation. Now what that did is it put an equation right here. I'm going to annotate again because I'm going to show you what that is. So here we see 7.19 x plus 2.82. This is equivalent to the y equals mx plus b slope equation, in which that m value is equivalent to the slope. So with this graph, by looking at this equation, I know that the slope equals 7.19, and that is equivalent to the experimental density. So since the slope equals 7.19, therefore the experimental density is 7.19 grams per milliliter. Now, we collected data in the lab for an unknown metal, and I know what the metal is. It's not the same data that you'll have here, so you will end up with a different slope. It's not going to be close to 7.9 if my memory serves me right. Sorry, I had an itchy back. So the goal of this experiment or this activity was for you to create this scatter plot, put the trend line in, use the equation to get a slope. Now we need to do something with this information. And the next thing that I want to teach you is how to take your information and compare it to what an accepted value is for your substance. This data set was for a set of pennies that were made after 1982. So they are pennies that contain mostly zinc with a copper coating. So I'm going to, because I don't remember, I think it's 5.6. These might have been pre-1982 pennies. They might not have even been pennies at all. Either way, I am not positive, so I'm going to use a pretend accepted value. I'm going to say that this is the metal that we used was called bankium. And the accepted density of bankium is 7.08 grams per milliliter. So we want to see how this experimental number compares to the accepted. So that's experimental. This is the accepted. Now you might need to do this calculation on a separate sheet of paper, and then maybe you can enter it into your spreadsheet. We want to do percent error. Percent error tells us how close we got to the accepted value. Now, I haven't told you what the accepted value is yet of this unknown metal, but I will. I don't want to say a value here because I may choose to use different metals in the future. Percent error is the experimental minus the accepted divided by the accepted times 100. Sometimes you'll see accepted minus experimental divided by accepted over 100, but it's always in an absolute value. So in this case, my experimental was 7.19 minus the accepted, 7.08 divided by the accepted, 7.08 times 100. And because of the order of operations, you have to take 7.19 9 minus 7.08 and hit equals so that that calculation has been done. Divided by 7.08 times 100 is a 1.55% error. In a chemistry lab at the high school level, anything below 10% error is considered pretty darn good. I'm just double checking my math. Yes. So what I would like you to do is I would like you to calculate the slope, figure out what your experimental density is. When you've done that, I will tell you what the accepted value is, and you can do a percent error calculation. And I have to clear this. All of this will be done on this sheet that you got that initially looked like this. So if I can review, you are going to add your data. You're going to do a calculation to determine the difference in the volume. You are going to take that information and the mass information, these two columns, and make a scatter plot in which you insert a trend line and add the equation. Then you will take the slope and use it as your experimental density in the equation that I provided. I want to show you all something really quick, and I would like you to do this as a last thing with your data. I want to do a density calculation. Density equals mass divided by volume. We have mass here and we have volume. I want us to use the equation feature again, equals, and I want to take the mass divided by the volume and hit enter. And then I want to highlight that box, hover over the little square and drag it all the way down. And you will see that most of the numbers here are around 7. There is one here that I believe would be considered an outlier. And I'm wondering what would happen if we got rid of it. It changed the slope a little bit. I'll put it back. So now what I want us to do is I want us to highlight this column. We're going to get an average. So we're going to highlight this column. Actually, I'll show you a different way. We'll use the equation feature again. Equals the average of, I'm going to highlight this, the average of that column. And it shows an average of 8.17. That doesn't make so much sense to me because it should be around 7.19. I'm going to think on that for a little while, but I would like you to do the same calculation as well and label this average density. Okay, so I will put a list of what I want you to do. This video shows you step by step. You're probably already done. I don't know why I'm telling you this now. It doesn't matter. So I'll just go ahead and do what I need to do. See you later. Thanks for watching.